Welcome to the CCNA question and answer. Remember to pause the video and answer questions. Question number 1. We have a scenario. We have ISP, router, switch, a server, and then different devices, which is host 1, host 2, host 3 to host 6. We have the connection from ISP to the router, from router to the switch with different IP address. So, refer to this scenario. A network technician is asked to design a small network with redundancy. The exhibit represents this design with all hosts combined configured in the same VLAN. What conclusion can be made about this design? A. This design will function as intended. B. Spanning tree will need to be used. C. The route will not accept the addressing scheme. D. The connection between switches should be a trunk. E. The router interface must be encapsulated with the 802.1. This choice does not provide any specific information or analysis about the design and its functionality. So it does not offer a valid reason for the conclusion. This is the wrong answer. Answer number 2, spanning tree will need to be used. Spanning tree protocol is not explicit mentioned in this scenario or this question. So it cannot be determined whether it needs to be used based on information provided. Therefore, this choice does not provide a valid reason for the conclusion. It's a wrong answer. Answer number 3, which is the correct answer. This scenario or exhibit shows all hosts configured in the same VLAN, which means they will share the same subnet. If the router is connected to this VLAN, it may not accept the addressing scheme if it is not configured to support the same subnet. Therefore, this choice provides a valid reason for the conclusion. Answer number 4, which is wrong answer also. This exhibit does not specify the type of connection between switches, so it cannot be concluded that a trunk connection is necessary based on the information provided. This choice does not offer a valid reason for the conclusion. E. The exhibit does not mention any specific requirement for the router interfaces to be encapsulated with the 802.1q protocol. Without this information, it cannot be determined whether this is a necessary step for the design. Therefore, this choice does not provide a valid reason for the conclusion. This also is a wrong answer. Question number 2. Question number 2. We have a scenario with router 1, router 2, router 3 with 2 devices. Refer to this scenario. When PC1 send a packet to PC2. The back packet has which source and destination IP address when it arrives at interface GI 0 by 0 on router R2. When PC1 send the packet to PC2, the packet has which source and destination IP address when it arrives at interface GI 0 by 0 on router R2. Answer number 1. Source 192.168.10.10 and destination 10.10.2.2. Answer number 2. Source 192.168.20.10 and destination 192.168.20.1. Answer number 3. Source 192.168.10.10 and destination 192.168.20.10. Answer number 4. Source 10.10.1.1 and destination 10.10.2.2. Pause the video and answer this question. The correct answer is C. Source 192.168.10.10 and destination 192.168.20.10 is the correct answer. The source IP address 192.168.10.10 is the IP address of PC1 and the destination IP address 10.10.2.2 is the IP address of PC2. This combination does not match the scenario described in the exhibit where the packet arrives at interface GI 0 by 0 on router R2. Answer number 2. Explanation. The source IP address 192.168.20.20 is not the IP address of PC1, and the destination IP address 192.168.20.1 is not the IP address of PC2. This combination does not match the scenario described in this exhibit, where the packet arrives at interface GI 0 by 0 on router R2. It's a wrong answer also. Answer number 3, which is the correct answer. The source IP address 192.168.10.10 is the IP address of PC1, and destination IP address 192.168.20.10 is the IP address of PC2. This combination matches the scenario described in this exhibit, where the packet arrives at interface GI 0 by 0 on router R2. This is the correct answer. Answer number 4. The source IP address 10.10.1.1 and the destination IP address 10.10.2.2 do not correspond to the IP addresses of PC1 and PC2 in the scenario described in this exhibit. This combination is incorrect for the packet arriving at the interface GI 0 by 0 on router R2. Question number 3. We have a scenario. You need to check this scenario with the command use show interface 10 gigabit internet 0 by 1 by 0, and we get this result. Check the result, this scenario. So refer to this scenario. Shortly after site A was connected to site B over a new single mode fiber path. Users at site A report intermittent connectivity issues with applications hosted at site B. What is the cause of the intermittent connectivity issue? A. Interface errors are incrementing. B. High usage is causing high latency. C. An incorrect SFP media type was used at site A. D. The sites were connected with the wrong cable type. Pause the video, answer this question. Answer for the question number 3. An interface error are incrementing. Interface error incrementing on the newly installed single mode fiber path can indicate physical layer issues such as faulty connection, dirty fiber ends, or misaligned fibers. This error can lead to intermittent connectivity problems between site A and site B, affecting application performance. This is the correct answer. Answer number 2, which is the wrong answer. High usage causing high latency would result in consistent performance issues rather than intermittent connectivity problems. While high latency can impact application performance, it is not likely the cause of the reported intermittent connectivity issue between site A and site B. This answer number 2 is wrong. Answer number 3, which is incorrect also. Using an incorrect SFP media type at site A could lead to compatibility issues and connectivity problems, but it would not result in intermittent connectivity issues. Incompatibility issues would typically cause a complete loss of connectivity rather than intermittent issues. This is the wrong answer also. Answer number 4. Connecting the site with the wrong cable type could result in physical layer issues and connectivity problems, but it would not necessarily cause intermittent connectivity issue. Using the wrong cable type would likely result in a complete loss of connectivity rather than intermittent issue. This is the wrong answer also. Explanation to all the answers. The only indicator of any issue here is the reliability 166 by 255 on site A. When the input and output error increase, they affect the reliability counter. This indicates how likely it is that a packet can be delivered or received successfully. Reliability is calculated like this. Reliability equal to number of packets divided by number of total frames. The value of 222.55 is the highest value, meaning that the interface is very reliable at the moment. The calculation above is done every 5 minutes. Question number 4. We have router, switches, and different devices with IP address and the subnet mask on those two devices. Refer to this scenario. When PCA sends traffic to PCB, which network component is in charge of receiving the packet from PCA, verifying the IP addresses, and forwarding the packet to PCB? A. Router. B. Layer 2 switch. C. Load balancer. D. Firewall. Pause the video and answer this question. The correct answer is A. Router. Answer number 4. Question number 4, explanation. Answer number 1, which is the correct answer for the question. A router is the network component responsible for receiving packet, checking the destination IP address, and forwarding the packet to the correct destination. It operates at the network layer or layer 3 of the OSI model, making the routing decision based on IP addresses. This is the correct answer. Answer number 2, which is the wrong answer. A layer 2 switch operates at the data link layer, layer 2 of the OSI model, and is responsible for forwarding frames based on MAC addresses. While a switch can forward traffic within a local network based on MAC addresses, it does not perform IP addresses verification or routing function like a router. It is a wrong answer. Answer number 3, load balancer. A load balancer is a device that distributes network or application traffic across multiple servers to optimize resources utilization, reliability, and performance. It is not responsible for receiving, verifying IP addresses, or forwarding packets between devices in a network. Answer number 4, a firewall, which is also a wrong answer for this question. A firewall is a network security device that monitors and controls incoming and outgoing network traffic. While a firewall can inspect packets and filter traffic based on IP address, it is not primarily responsible for receiving, verifying IP addresses, and forwarding packets between devices like a router. So this answer also is wrong. Next question. We have a scenario with router, 4 routers, and 2 devices connected to the routers. So we use the command IP router 0.0.0, 10.10.10.2. Then we use different commands on those different routers. So refer to this scenario. R1 has just received a packet from host A. that has a destination to host B. Which route in the routing table is used by R1 to reach host B? A. 10.10.13.0 by 25 1 by 0 via 10.10.10.2. Answer number 2. 10.10.13.0 by 25 108 by 0 via 10.10.10.10. C. 10.10.13.0 by 25 110 by 2 via 10.10.10.6. Answer D. 10.10.13.0 by 25 110 by 2 via 10.10.10.2. The correct answer is B, or 2. 10.10.13.0 by 25 108.0 via 10.10.10.10. Question number 5. Explanation. This route specifies the destination network 10.10.13.0 by 25 with a next hop of 10.10.10.2. However, the metric value is not provided, so it is not unclear whether this route is the best path to reach host B, so it is not the correct answer. Answer number 2. Specify the destination network 10.10.13.0 by 25 with a lower administrative device 108 and the next hop of 10.10.10.10. The lower administrative distance indicate that the route is preferred over others in the routing table, making it the route used by R1 to reach host B. This is the correct answer. Answer number 3. Explanation. This route specifies the destination network 10.10.13.0 by 25 with a highest administrative distance 110 and the next hop of 10.10.10 by 6.6. The higher administrative distance indicates that this route is less preferred and not used by R1 to reach host B. This is the wrong answer. Answer number 4. This route specifies the destination network 10.10.13.0 by 25 with the same administrative distance 110 as choice C, but with a different next hop of 10.10.10.2. Since choice B has a lower administrative distance and the same destination network, this route is not used by R1 to reach host B. Remember, we have the course which will help you to understand CCNA, course of 540 question and answer with free PDF of over 800 question and answer. We have more than 400 scenario well explained which will help you to prepare your CCNA test. Remember to subscribe to this channel, click like, write a comment. Hope to see you for different lesson of question and answer. Check the link in description if you need to take any course which will help you to pass your CCNA or other test. I thank you so much.